Okay, so moving on to this one. All the directions just say, if it's not already factored, factor it. Identify the zeros in the multiplicity, and then the end behavior, and sketch the graph. Okay. So this one's already factored. Yay. So, a little less work. If I set each one of those equal to 0, that's how I figure out what my zeros are. So what are my zeros? -2, 1, and 3. And what are the multiplicity of those zeros? Yeah, they're all just 1. I'm sorry. Okay. They're all just 1. So I've got that. Now, what we don't know is the degree, although we can kind of figure it out. And I'm not going to multiply this all the way out. I'm only going to multiply the first terms. If I multiply the 3 x's, that gives me x cubed. So I know that's the first term. And I can figure out the last term too real easy. I just multiply all the last numbers. +2, -1, -3. So 2 times -1 is -2. -2 times -3 is +6. It doesn't really matter what's on the inside. It sounds bad.
Teachers, excuse interruption. I need 9th grade last name V through Z. Report to the presentation room, V through Z.
Okay, so then we have x cubed. And so x cubed means that the degree is odd. So what does that tell us about how it points? Opposite. And then the leading coefficients, so let's look at those numbers in front of all the pink x's. They were all 1, right? So this is a positive 1x cubed. So our leading coefficient is positive, which tells us what?
It's going to go up on the right.
Yeah, points up on the right, down on the left. And what does this +6 tell us?
The y-intercept.
That's the y-intercept. That's where it's going to go through on the y-axis. Okay, so let's put the zeros in. And I'll go through 6. I know it's going to go down this side. Oops. Oh man, I hate it when it tries to straighten out the line. It'll look something like that. 6 may have been its highest point, but it might not have been either. We just don't know. Same thing with 2 down there. That could have been the lowest point there, or could have been down farther. I just know it has to have this shape, it has to be pointing in these directions, and it has to go through those points. All right, Tyler, give me the zeros.
-1 and 2.
Yeah. And what about the multiplicity of those zeros? Anybody?
-1 would be 2, and 2 would just be 1.
Yeah, so because x plus 1 is squared, that means it has a multiplicity of 2. So it's going to be tangent to the x-axis. Now I've got to do a little multiplying here. This is x, but it's x squared. So that's x squared times x. So that's x cubed, and it's 1x cubed. And then when I multiply the last numbers, I have positive 1 squared, which is 1, times negative 2, which is negative 2. So it's odd, so they point in different directions. Leading coefficient is a positive 1. So just like the last one, down on the left, up on the right. And it's going to go through y equals negative 2. So I have negative 1, positive 2, and it goes down here. Let's see, I know. So it starts down, and it bounces there. It's going to look something like that, have that basic shape. You try the next one.
Teacher's excuse interruption. I need 10th grade last name A through C. Report to the presentation room. 10th grade A through C.
And Donna, give me the zeros.
Negative, wait, no.
Mm-hmm.
Wait, did you, that negative and, outside the parentheses, does that count towards the,
If it did, it would cancel it out because it goes with both of them.
okay,
So,
negative 2 and 2.
yeah. And then what are the multiplicities, Justin?
They both have multiplicity of 2.
All right. And if we multiplied those together, what would the degree be? 4, yeah. Then multiply them together is x squared and x squared. And x squared times x squared is x to the 4th. And notice this negative. Now that's where this negative really comes into play. It's out in front. So when you square everything, that's not squaring that negative. So it's going to be negative x to the 4th. And then when I square the back numbers, I have 2 squared is 4. Negative 2 squared is also 4. 4 times 4 is 16. But there's that negative there. So that's going to be minus 16. That tends to throw people off, so be careful there. So, Jenna, what's the leading coefficient? -1. Good. So how's this going to look, Jose? What's it going to, up, down, left, right? How's that going to work?
Looking down.
Yep, they're both down. Down on the left and down on the right. And then what would the y-intercept be, Gisela?
-16.
Yes. There you go. So now we just grab. Okay, so I have -2, +2. Somewhere down here, -16. They're both pointing down, and they both have a multiplicity of 2. So it's got to do that bounce thing. So something like that, kind of like an M. It doesn't have to be perfectly symmetrical. Can be. We don't know yet. Kind of getting a feel for these, hopefully. That's the hope. Okay, so for the next one, set each of these equal to 0. You just get -3 and 1. The multiplicity for -3 is just 1. What is it for 1? Yeah, because it's cubed. So that's going to do one of those changing concavity. So what would my degree and leading coefficient be when I do this little multiplying thing in here? Yeah, it's going to be x to the 4th.
Teachers, excuse the interruption. 10th grade, last name D through F. Report to the presentation room, D through F.
Because it's x cubed times x. So that's where the x to the 4th is coming from. And then -1 cubed is -1 times 3. That'd be -3. Okay, so the degree is even. The leading coefficient is